Morning, students. So today's topic is counting the number of memory cells. This is much easier than the previous laboratory work, but today you will get to have an additional task. So that should be performed after the laboratory. So that may be assigned as assignment 2. So let's just telling you that what is an asymptotic notation. So the asymptotic notation is just a crude measure how the tendency of a function is related. So if you have a function, which is somewhat value of 1, value of half, value of 2, sometimes 1, half, 2. So the tendency of this function is much like this. Another function maybe has a similar tendency, but somewhat gear-like tendency like this. So another function may be slightly curved like a sine curve, okay, like this. So you may think about this. All these functions can be bound to a certain level like this. Okay, so all the functions can be estimated with the crude measure that this line, under this line. So think about another approach of the function, maybe someone like this. It starts from 1, but it is increasing like this. So another function may be sometimes it starts from 2, but sometimes at first it is decreasing a little bit, but it is increasing after that. Another function maybe starts from 0, but it is rapidly increasing like this, but it is still a line. Then you may think about that all these functions is bound under this line. Okay, so these kind of measures is sometimes called asymptotic. Asymptotic means that it is just a crude measure. So where it is good. So it is just a crude measure of it. So it is much like that they have a special notation for this. For the first case, they are telling that it is order of 1. For this case, they are calling this as order of n. Even though the order of n is not exact to fn, where fn is just equals n. Okay, but you can think about that. The only good point is that important point. Order of 1 means that it is a set of functions. These functions are all included in the order of 1. So let's discriminate this function as sine function as Sn. How about this function? Maybe it is like your like your teeth. So Pn may be your the notation for that. How about this? It is much like a worm, so Wn can be considered. So exact notation of order of 1 is much like a set of functions including Tn, including Sn, including Wn. Okay, but it is tedious to use this kind of set notations every time. So they have a notation that T of n is just equal to order of 1. So in fact, the meaning of this T of n is a member of order of 1. Similarly, so you can find that it is much like that F1, Fn, or Gn and Hn, maybe. So actually order of n is a set of functions including Fn, Gn, Hn, and more. Actually infinite number of functions. But this send notations is somewhat tedious sometimes. So you may telling that Fn equals order of n, and the equals means Fn is or has an order of has an order of. Okay, so anything will do. So this means that Fn has the property of big O of n. So it just like that Tn has some property of big O of 1. Okay, so it is good to know to understanding that order notation is a crude measure, but it is somewhat exact. That means I can tell you that you are pretty, but then maybe inexact. I may telling Junyoung that you are handsome, but then maybe inexact because there's no someone does not agree on that. But if I telling you that Junyoung, you are a human being, and that is a very crude statement, but it is very exact. Okay, so we will make an exact statement with inexact measure. Okay, actually not inexact, but it is exact, but it is somewhat like a crude measure. So it is called asymptotic notation. Okay, so with this asymptotic notation, you may count the number of operations, and you may count the number of memory consumptions. So this is the idea. So do you have any questions or unclear point on that, on the asymptotic notation? No? Okay, so let's just jump into today's question. But before that, I'd like to just introduce the GNU plot. It's the GNU plot. So let's just save this and delete all this. So the GNU plot is also included in GNU. As you know, do you remember GNU? What's GNU? Do you remember this one? Okay, I can check the chatting. Yes, GNU is not Unix. So yes, that is correct. It is included in GNU, and this is a shorthand that GNU is not Unix. So it comes from that some Unix is commercial at the time. So they want to a free operating system. So they actually the Richard Stallman just initiated the Free Software Foundation, and he ported every code to GNU. So it built up GNU as a new operating system. But as you know, the definition is not saying that it is not Unix. So it can be anything. So some guys just made tools. So GnuPlot is a plotting tool. Plotting means it is much like a drawing, but drawing graph. So they are drawing graphs, something. So it is much like a graph drawing tool. So a graph drawing program called GnuPlot is useful to visualize the result of measures. So we will not use this. You don't have to practice this today, but it is good to understand how to handle it. The basic command of it is plot. The plot is the basic command. So you can download it from the sourceforge.net. So I'd like to just resharing this and click this. So you can download GnuPlot here, download the latest version. If you click this, it will be downloaded in several minutes, several seconds. So you can just click and next and next. So it will just make a GnuPlot. So I just downloaded and installed the GnuPlot here. So you can execute any of them. So I'll use this. Just click this. How about this one? Okay, so GnuPlot. And at the end of the installation step, so beware that just mark the GnuPlot in your path environment variable. Okay, so if it is not, you have to add it manually. So you can do it, but it is tedious. So please just check that. Click the enable, add your path. So I'll use this in later this phase. So I can reshare this again, your handout. So today we'd like to recursion and call stack. The concept of recursion is that you are calling some subprogram and it do some work and coming back to you. But recursion means that a function may calling itself. That is called recursion. So think of that. You have a main function and you are calling scan function, scanf, and then scan do something and coming back to main. That is the concept. Or more sophisticated, you have a main function and you are calling another function f, and function is the help of another function g, and g is returned to f is returned to main. That is the concept. So they are calling this as return, which means they're coming back to main. So coming back to f. So you are saying that some function is a caller of g, but it may be caller of some another function. But you can have a very peculiar function that you are telling your brother, hey, please give me your pen. Your brother may telling your sister, hey sis, please give me a piece of pen. And your sister may telling you again, hey, please bring me a pen. So what's this? So the main calls something, but brother calls your sister, and sister calls you again. This is you. Then it is called a recursion. So recursion is somewhat hard to handle because it loops. It loops forever. It can loop forever. This is called an indirect recursion. So this is called indirect recursion. But in some cases, it may have a direct recursion. Think of that. You are calling your main function is calling add function, and add function is calling itself. So it is calling itself. So it has, the recursion has always has some difficulty, it can be go deep into the indefinite loop. Okay, this is called a direct recursion. So it can be indirect loop. But if you code it carefully, then it can do a useful thing. Okay, so I'd like to take a look a very useful work today, which is called add function. So recursive algorithm is generally compact than the iterative counterpart. So this is a very good advantage of recursion. It is compact. But it has two disadvantages. This is an advantage. So it is good. But disadvantages, one is inefficiency. So this is a bad point. One is that it can be inefficient. So sometimes it can be indefinite. It is not described here. So infinite loop. So this is a second disadvantage. So it is bad in this respect. It is also bad in this respect. Okay, but this advantage is very useful sometimes. So you have seen that recursion do a useful thing in the past lecture. In that case, you have R-fib, recursive Fibonacci number n, then R-fib can be represented as R-fib minus 1 plus R-fib n minus 2. Okay, so it reflects the structure of the definition of the Fibonacci number. So it is very compact and useful. Okay, so the main reason for this inefficiency lies in the cost of maintaining a calling stack. So it is related to the core stack here. So the idea is like this. So in your main, you have a local variable a here. Okay, but your add function itself has another local variable. It is a parameter actually, but it is considered as a local variable. Another local variable b. So your computer should remember what is the value of a in main. So you should remember if a is 2, so you should remember it. But it transfers, it is calling add. So the add needs two variables. One is a, the other is b. But they have the same value, which is the same value of main. But it needs two other variables for that. Okay, so they are calling this as a frame. This is a frame of main. So main's frame, main's stack frame. This is another frame for add. And the recursion may call itself, then that means add frame may be stacked up here. So it is called stack. Another add frame may be stacked up here. So with this crude thing, a minus 1, so 1 is added here, incremental b, and 3 may be added here. Okay, so the stack frame should be increased accordingly in a recursion. And it has more. So I just exemplified just the local variables in this stack frame, but it has more because you should come back to this frame. Actually, your stack is maintained two pointers. One is a base pointer. The other is a stack pointer. They are using two pointers, which is just the bottom of the frame and just top of the frame. So they have two pointers. So the 2 pointers should be saved because the previous frame should be recovered. So after after returning this add, the current base pointer should be a stack pointer, and it should be reset as base pointer should be reset like this. Okay, so it has more memory cells are needed for stack pointers and base pointers and other values, other maintaining jobs. So this is the main cause of inefficiency of recursion. For example, the following code shows a duplication program, so which accepts an integer value and it prints the duplication of it, a double value of it, with a recursive summation function add. So this is not a good name. It is not duplication, but double up program. Double up program with a recursive summation function. So you have a main function, it reads an integer. So I just use the prefix std : here to save the space. Okay, so in order to use it, so you have to add a single line using namespace. And I also, this is not a good style, but I also added a brace in the same line of the function header. Okay, this is not a good practice, but it is just layered in this style to save the space, okay, space of your handout. So anyway, it is reading an integer and it is calling add, and the add is returning b if a equals 0. So it is very simple, but if it is not, it is decrementing the first parameter. And second parameter increment is just exemplified b. So it has the same meaning of b plus 1, but I just here made it here for the demonstration. Okay. Therefore, the above code is extremely inefficient than the iterative version, even if the iterative version is also inefficient. So let me show you this. Show you this in your terminal. So I'll just switch it to the terminal here. Sorry for that. Okay, so I'm sharing this, and I'd like to change this 2000 DS and lab 2 collect count, and I have several functions. So if you just collected this, just use a pangman -s to make. Okay, so if it is so, then the make utility is updated to you. Then you can just like to find add1.cpp. So this is the function. So without make, you can do g++ add1.cpp and then execute it a.exe, and it is waiting for your input. And you know that if you enter 5 and 10 is returned, printed. But if you have make, once you install the make, then you can do the similar thing, make add1 without the .cpp. So let's delete add1.exe and make add1. So it will do add1 automatically. Then add 1.exe is executed, and if you enter 5, it prints 10. Okay? So just install in your MSys pacman-s make if you like. Okay? So the measuring memory, so I'd like to reshare the handout. So measuring the memory consumption of an algorithm is another concern of algorithm designers. One way to measure the memory consumption is by counting the number of memory cells. As you know, the number of memory cells may be different depending on types, but to make it simple in this exercise, in this laboratory, you just consider that every variable has the same size of 1, okay, in the middle of your code. For example, the number of memory cells required to execute a function can be counted by 2 variables. So this is somewhat complicated at first because you need 2 variables here. So one variable is current count, so the current consumption of the memory, and max count is the maximum consumption. So let's think about that. You have a time domain here. This is the memory consumption. Then at first it should be 0, but once your program is executed, it may be increased. And it can be decreased in sometimes. Increase, decrease sometimes, but it can be increased sometimes. So at the end it is terminated here. But you have to remember, what is the maximum memory consumption? This should be counted. So this is for max count, and this curve is counted, will be counted with current count. So the max count is examined when your current count is increasing. Okay, so let's take a look. So the current count is counting the current number of memory cells, and the maximum, the second one, max count, is counting the maximum number of memory cells respectively. And the previous program can be converted as follows: current count and max count. Once the increment function is executed, it has a parameter n, so this parameter n is added to the current count. And this magic number 3 is just saved to store stack pointer and base pointer and return value. So just this is the minimum one, so you just add number 3. It is a constant value for every function call. So the function, for the function call, add 3. So since you incremented the current count, it is compared with the max count. If it is greater than max count, you set max count as current count. And before returning m-1, current stack frame will be decreased eventually. So you are decrementing this current count before returning the m-1. So it is silly if you add current count return n+1 and then decrement current count -4 by 4 is silly because it is unreachable code. Okay, so you have to make this code is reachable before returning m-1. So I just added this to this point with the comma operator. Do you know comma operator? In C and C++, they have comma operator. So expression 1, comma, expression 2, comma, expression 3 can be assigned a variable x, which is the value of the last expression. But these expressions are executed before the evaluation of E3. Okay, that is the meaning of comma operator. Okay, so I used brilliantly the comma operator here. So save this. And this, in the same way, you can add some audit code in the add function and add function. Okay. So in the add function, you added where it is. Okay. So you added +3 for the function call, the base pointer, which is also called the frame pointer, stack pointer, and the return value. And this +2 is incremented by 2 because you are accepting 2 parameters. Since you are incrementing current count, it is compared with the max count. If it is greater than max count, it is set. And there's another tricky one is that since add is a recursive version, okay, so the stack frame is not decremented until this add recursion is returned. So you need another variable which is denoting return value. Actually, RV stands for return value. So RV is set as the value of this recursive call, and the current count is decremented after that. Is this meaningful for you? It should be decremented after that, and then RV is returned. Okay, so you save this, and as you know, this is the unit. This is the unit. It is not the closing parenthesis. RV is set, and current count is decremented after that, and RV is returned. Okay, and you need, this is essential, and you need this parenthesis because the comma operator has a lower precedence than the conditional operator, even though it is a higher precedence than the assignment. So the comma operator has a lower precedence of the conditional, but higher precedence than the assignment. Okay, so without this, your conditional operator bind to this point. Okay, so in order to make it the control flow as you want it, you have to enclose this sequence of comma, a sequence of expressions bound by comma operator to be enclosed in a pair of parentheses. Okay. So note that the memory overhead of a function call is counted by the constant 3. Also note that comma operators sometimes with an additional value of RV, comma operators are brilliantly used to count the maximum number of memory cells without changing the semantics of the function. So let's just modify this. Let's take a look in your terminal. So in your terminal, I already have a function add one count. Let's see. No, what's wrong? Oh, add one CPP. Sorry, add one count the CPP. So I encoded current count and max count, current count and max count, and the addition result is printed. Max count is printed after that. So you make, it is already made here. Add one, the current function add one, the cnt.exe is already made. So once you enter 2, memory consumption is 15 cells. Add one count exe for 5, 30 cells. Add one count exe 10, 55 cells. Okay. Also, I just made add tab the CPP, which is very similar to add one count. Okay, but instead of receiving a value from standard in, it is the value of A is starting from 10 and it is incremented up to 100 and it is incremented by 10. and the current count and max count is reset as 0, and it is applied calling add a and a, and the value of a and max count is printed here. So in order to use printf, you have to include cstdio. So it is very simple convention that in your, if you have in C domain stdio.h header file, then in your C++, you just prefix C stdio in your C++ header file. So how about if the header file starts from C? So how about C-type.h? Just blindly made C. So C type. This is a header file name, C++ in C++. Okay, so I just made it because I want to use printf here. So printf is more good in formatting, more convenient in formatting. So I just exemplify that. Okay, so let's make add tab. The mouse. Make add tab. Then it is recompiled since your add tab is just modified. And add tab is executed. And you can store the result with a redirection. Add tab.exe is saved as add tab.txt. Okay, you can check cat add tab.txt here. Okay, so I can just reshare you the whole screen. So you can make an explorer here. Then the current window is opened, and you can just right click or shift to right click, then you can issue the command prompt here. So once you added GnuPlot in your path, you can use it, GnuPlot here. Okay, then you can plot what was the name, add tab.txt. Can you see? Can you see this? So control. Can you see this add tab.txt is it is plot in this graph. So if you need a line for that, plot add tab.txt with line. Okay, so it is a straight line. So you can imagine that the memory consumption of this add program is order of n. It is like a linear line. It is bound in beneath the linear line. Okay. Okay. Do you have any questions up to here? No questions. Okay. Everything is just evident. So today's problem is cell count.cpp. So measuring the number of maximum memory cells of a factorial program, but you have two versions, iterative factorial and recursive factorial. So the recursive factorial, can you see that the R-fact is calling itself? So R-fact is calling itself, okay? And I-fact, there is no I-fact inside of this here. Okay, so this is an iterative version. This is a recursive version, iterative version. So for two versions, you can execute the factorial. The result should be same. And add two counting variables as above to measure the maximum number of memory cells consumed by each function. And assume that the size of variables are all counted by a unit size, which is 1. regardless of the type. You may think that long has a very long, much bigger size, but just assume that it has the same size with int. The following shows the input and output of two simple cases. So let's take a look. 0, the factor 0 is 1, consumed by iterate, what is it? Recursive version, iterative version. So for the 0 case, recursive version can be more efficient, but it is not general. In 2, recursive version prints consumes 12 memory cells, but iterative version just consumes 6 memory cells. Okay. So do you have any questions? No questions? Then thank you for joining to this lecture, the second laboratory lecture, and see you on next Wednesday. Thank you all and bye-bye.